Hello everyone, welcome back to my YouTube channel. Today we'll discuss about interconversion of Fisher projection formula to Sawhorse and Newman formula. The understanding of interconversion of this formula is very important from competition point of view, as well as it is an important skill for organic chemist. It will help you to learn the arrangement of different atoms and groups across the chiral centers. And the same understanding would help you to identify between erythro and trio isomers, because when questions are asked about erythro and trio isomers, sometimes the structure is not given in the form of Fischer projection formula, which is given over here. This is the Fischer projection formula, and sometimes the structure is given either in the form of Sawhorse formula or in the form of Newman's formula, and in that case it is quite difficult for the student to identify directly, while for Fischer projection it is quite easy to identify between erythro and trio isomers. So if that is the case, if you have the knowledge of interconverting the Sawhorse back to Fischer or the Newman projection formula back to Fischer formula, then you can easily solve those questions. So let us begin with the rules for converting these formula. And the Fischer projection formula is always written in this form, and then we have Sawhorse formula like this, and if Newman's formula are to be given, that they are mostly like this. Anyway, so this is the tartaric acid which is shown in the form of Fischer projection formula. And now if you want to Sawhorse form, then the first step is to draw a line, and a slant oblique line, and draw two letters Y, one at the top end of this line and second at the bottom end of this line. Draw two Y letters like this, it's shown over here. You can see here that COH is given at the top on line perpendicular to the line connecting H and OH. So write COOH over here, and one COH is at the bottom, so the other would be like here, to be written here as in this case. And now since H is on the left side, write H on the left, and OH again on the right side, put OH on the right. Again carbon, the front carbon, again H is on the left and we have OH on the right. So this is the eclipsed form of this Fischer projection formula, but the correct form is the staggered form. So once this form is written, what we have to do is to rotate this front carbon by 180 degree, means we have to turn it upside down 180 degree, as it is written over here, rotation by C2 C3 axis by 180 degree upside down. So when you make it upside down, this COH will go up. You can see from here also this COH will go up, this OH will come over here, this H will come over here, and COH will go over here, and a new structure will be formed. This structure is the correct representation of the Fischer projection formula of tartaric acid. Similarly, as we do it for Sawhorse formula, the same concept is utilized here, but here instead of drawing a slant line, we draw circles. We draw a circle here, and on this circle we draw 2Y again. The same letter Y was drawn on a slant line in case of Sawhorse formula. Then another Y is to be drawn in eclipse position. So draw, and since it is the rear carbon, so it is not visible completely. All the bonds are not visible completely. The groups at the top and bottom should be again written over here. COOH for the back this carbon. 1, 2, 3 and 4. So this one is the third carbon. This is the first carbon. This is the fourth carbon, COH group. Then we have H left, OH right. Again in front also we have OH on the right, H on the left. Again we rotate it by 180 degree to make it upside down, and once it is upside down it forms this. You can see in this structure, because when we rotate it, when we rotate the front carbon, as in case of Sawhorse formula, we rotate the front carbon, here also we rotate the front carbon, so this COH will go to the top, and when this COH will go to the top, OH will come to this side, left side, while H will go to the right side, while the back carbon, the rear carbon, remains same. There is no change in the position of H as well as OH. So this is the correct representation of Newman Fischer projection form of tartaric acid into the Newman projection form of tartaric acid. Now, as I said, in case of erythro and thioisomers, students, although it is very easy to identify the erythro and thioisomers in case of Fischer projection formula, as the case in this particular form, if somebody asks you the Fischer in this Fischer projection form of tartaric acid, so it is clearly it is the erythro isomer. But most of the time when they ask this question, instead of giving Fischer projection form, they generally give the Newman form or the Sawhorse form. So if in case you have been asked about erythro and thioisomers and you have been given Newman and Sawhorse form, then you must also, because I hope that after watching this video you would be able to interconvert those Newman and Sawhorse form back to Fischer form, and then once it is form is obtained, you can easily identify whether it is erythroisomer or thioisomer. So let us check those examples as well. So this is the structure that I have shown here for your understanding. So here a Sawhorse form is given for a molecule and you have to convert it into Fischer form. So first of all, by 180, so front carbon and will be rotated, there will be no change in the back carbon. Back carbon we have NH2 over here, then Cl over here, then Me over here, and when we rotate this carbon, pH will come to the bottom, the phenyl ring, and the position of OH and Br will be replaced. OH will come this side while Br will go this side. Now when this form is obtained, what we can do is we can directly convert it into, or we can directly write the Fischer form just by drawing a line, then drawing two perpendicular line, Me on the line showing downward, it is written over here because it belongs to the rear carbon, while pH belongs to the front carbon, it is written over here, and NH2 on this side, so it will be written like this, Cl on right side, similarly OH on left side and Br on the right side. So in this way you can easily write the Fischer form from a Sawhorse form. So for converting Newman form to Fischer form, again what we can do is, because it is already written in this form, so what we do is rotate it, the front carbon, by 180 degree without disturbing the back carbon. So when we rotate the front carbon without touching the back carbon groups will remain same. Br will be untouched, it will remain at its position, OH this side and pH on this side, while the front carbon will go like this. And we have Me, NH2 and Cl, and in this way we can, in the next step we can write the Fischer form from this Newman form. So I hope with this video you have learned about the interconversion from Fischer form to Newman and back vice form, and with the help of this video you would be able to solve questions relating to identification of erythro and thioisomers. Thank you very much.